Have you ever wondered what happens when you click a button on a website? Where does your data go? Today, we are learning servlets, the brain behind Java web apps. A web app has three layers: client, server, and database. Application and browser have been included in the client tier, right? For an example, when you log into Instagram, your browser talks to a server. That server runs something like a servlet. The browser requests the server and the server responds, right? This is the browser request, right? And this is the server it responds, right? Like this. Request and respond. Okay. Servlets sits in the middle like a waiter in a restaurant, right? This is the servlet. Okay. What are the jobs of servlets? Read data and process and send response, right? There are two types of data a server receives. Explicit data, what the user types in forms, right? Implicit data, extra information sent automatically by the browser. When a user submits a form, the browser sends the data to the server, and the servlet reads that data using methods like getParameter. See, let's discuss implicit and explicit data in detail. Explicit data is the data the user intentionally sends, like form inputs, right? What are the examples? Username, password, email, search text. This is the example code, right? What about implicit data? Besides form data, the browser also sends hidden information called request headers, right? What are the examples? Browser types, language, cookies. Let's talk about dynamic pages, right? A dynamic web page is a page that changes based on data, users or time, right? Then dynamic pages always change, right? Think when you search something on Google, do you see the same result as your friend? No, because the page is created based on what you typed. What are the examples? Search engines, login system, order confirmation, right? Servlet reads your input and builds a custom page, right? In dynamic pages, data changes frequently. How? Think if a website shows today's weather. Should it stay the same forever? No. Exactly. The data keeps changing, so the page must be generated dynamically, right? What are the examples? Weather, stock prices, and news, right? The next point is data from databases. Think, where does Amazon get product prices from? From a database, right? Servlet connects to database and gets data and builds page, right? What are the examples? Product list, user profiles, student records. Relatable for you, right? Imagine you open an online store and each product has price, stock availability, right? These change every second, right? Then a servlet fetches latest data and build the page dynamically. So we build dynamic pages because users give input, data keeps changing, and information comes from databases. Dynamic web pages are like a restaurant chef. You order something, chef prepares it fresh, not pre-made, right? If a servlet is just Java code, who runs it? That job is done by something called a servlet engine, right? A servlet engine is a software that runs and manages servlets, right? It acts like a middleman between the browser and your servlet, right? What are the examples? Apache, Tomcat, Jetty, right? In real projects, we use tools like Apache Tomcat to run our servlets, right? Browser requests to the servlet engine and servlet respond to the browser, right? These are the steps, right? First one, user sends request, right? And second one, servlet engine receives it. Third one, engines find the correct servlet. Fourth one, calls servlet methods like doPost and doGet, right? Next one, gets response. The last one sends back to browser, right? Servlet never talks directly to browser, right? The engine handles everything. What does servlet engine do? First one, loads servlets. When the server starts, it loads servlets into memory. Second one, manages life cycle, right? Engine controls when these methods run. Third one, handles requests, right? Each user request is handled by the engine and passed to the servlet. The next one, multi-threading. Multiple users, no problem. Engine creates separate threads. The next one, security and configuration. It also handles things like security and web.xml configuration. Think of a servlet engine like a restaurant manager, right? customer is equal to browser, and waiter is equal to engine. Chef is equal to servlet. Customer never goes to kitchen directly. Servlet is not equal to server, right? Servlet needs a container to run. Servlet engine is responsible for running servlets, managing life cycle, handling requests, and sending responses. To create your first web app, create a new project. File, new project, go with Java and Java web application, right? Next. I keep this default name. Click on next. Next. Finish. Right. This is our project, right? Now, go to your source packages and click on default package and right click on it, new servlet example. Next, click on this, finish. This is our first servlet file, right? I change this to hello is right. Now you can run it. Okay. Remove this, right. Now run again. Okay. Copy and paste it, right? Yeah, sorry, paste it. See, now you can see our output, right? Hello is real. See, you can see this through your web browser. When we write a servlet, where do all those classes like HttpServlet come from? They come from special Java packages designed for web development. A package in Java is just a connection of related classes and interfaces. Servlet packages give us ready-made tools to build web applications. First package, javax.servlet, right? This is the base package for servlets. It contains interfaces and abstract classes, right? It works for any protocols, not just HTTP, right? It's like the foundation general rules for all servlets. The next one, javax.servlet.http. This is the package we use in real web applications. It is designed specifically for HTTP web, right? It contains HttpServlet, HttpServletRequest, and HttpServletResponse, right? Whenever you build a web app, you mostly use this package, right? The HTTP package is built on top of the generic servlet package, right? We can represent it like this, right? Where do these packages come from? Apache Tomcat, right? When you install Apache Tomcat, These packages are already included this path, right? This jar file contains all servlet classes. Think of it like this. Java Servlet is equal to basic vehicle rules, and Java Servlet HTTP is equal to rules for driving on roads, right? HTTP package is built on top of the basic servlet package, right? We can represent it like this. But remember, JAVAX is used in all the projects, Java Enterprise, and all the Apache Tomcat versions, included Tomcat 9 and below versions, right? Jakarta is used in modern projects and Jakarta EE. Newer Apache Tomcat versions included Tomcat 10 plus versions, right? The EE was moved from Oracle to the Eclipse Foundation, and it was renamed to Jakarta EE. Because of that, JAVAX.* is old, Jakarta.* is new version, right? You cannot mix them, right? This won't work, right? So, you should remember, if your server is old, use JAVAX. If your server is new, use Jakarta. In this case, same classes, same logic, only the package name changed. See, this is old version, this is new version, right? If I create a servlet, what actually happens inside it? Every servlet follows a fixed structure, like a life cycle, right? A servlet is like a worker in a company. Init method. It is like joining a company. This method runs only once when the servlet is created. What are the use cases of this? Connect to database, load data, right? Servlet is born here. The next part. Service method. It is like doing the work. This runs every time a user sends a request. It handles all requests. Internally calls doGet method and doPost methods, right? This is where real work happens, right? The last one, destroy method. It is like leaving the work. This runs once when the servlet is removed. What are the use cases? Close connections, free sources. Servlet dies here. Free resources, right? We usually don't override service method directly, right? Instead of, we use these things, right? Java automatically calls these methods for us. We can represent it like this, right? You can see initialized once, serves many requests, and destroyed once, right? When you open a website, who actually create that HTML page will generate a web page using a Java servlet. A servlet doesn't return a file, it builds HTML dynamically and sends it to the browser. This is the code snippet, right? Look at this line. This tells the browser, hey, I'm sending HTML, not plain text. Without this, browser may show raw text. This is the result of this code is not right. Look at this line. This is how the servlet writes data back to the browser. It's like opening a pen to write the response. Look at this. This tells the browser what version of HTML we are using. It helps the browser render the page correctly. Look at this part. This sends HTML code line by line to the browser. You are literally printing a web page from Java. This is what the browser gets and renders. Writing HTML inside Java becomes messy quickly. That's why technologies like JSP were introduced. For HTML validation, we can use W3C markup validation service, right? You can paste your generated HTML here to check for errors. When you open a website, where does everything actually lie? All parts of a web application are organized together in a structured way. A web app is like a project folder that contains everything needed to run a website. You can see the folder structure, right? Web pages, web index, source packages, like this, right? All these are packaged together as one application. This is the URL structure, right? This is the server, right? This is app name, right? This is the resource. For an example, if your app name is shop, URL becomes this, right? Every web has its own unique prefix. This is the web XML file, right? It's like the configuration file of your web app. What this map URL to servlet stores settings, controls behavior. Think when you type a URL, web.xml helps the server decide which servlet should run. So, when a user accesses a URL, server checks web app folder, looks into web.xml and finds correct servlet and executes it. Right? Think of a web app like a university. Departments are equal to components such as servlets, JSP, right? Building is equal to directory structure. Rules are equal to web.xml. Finally, we can say a web application is application or components organized in a directory, accessed via URL and controlled by web.xml. Web application is collection of components, right? If I build a full website, how do I move it to another server? That's why we use something called a WO file, right? A WO file is just a zip file that contains your entire web application. All your HTML, servlets, JSP and configs are packed into one file. We have three purposes of the web applications. The first one is organization. In this case, instead of files scattered everywhere, everything is neatly organized in one place. This is an example, right? It's like a well-organized project folder. The next one is portability. You can take your entire web app and move it to another server with just one file, right? Build your app on your laptop, upload, run on server, right? Servers like Apache Tomcat can directly run WoW files. The third one is separation. Each web application runs in its own space, right? We can break it down like this. Please remember these things, right? One app can't interfere with another app. For an example, if one app crashes, other still runs. So, WoW files help us to keep everything organized, move apps easily, and run apps independently. Think of WoW file like a lunchbox. Organization is equal to all food packed neatly, and portability is equal to easy to carry anywhere. Separation is like your food is separate from others, right?